Hello everyone, this is Tom from TutorBros. What an excellent day to do some math. Today we're going to learn how to solve a system of linear equations using the elimination method, also known as the addition or subtraction method. This method works best when we have a pair of terms, either the x terms or the y terms, or whatever variable you're using, that are either identical terms or opposite terms. So for example, if we look at this first system of equations here, you'll notice that the x terms are opposites, namely 3x and negative 3x. Now that's important because with this method, what we can do is we can add the two equations together in order to eliminate the x terms, and we can create a new equation with just the y terms and solve for y. And then we would go back and solve for x. So again, we're going to add the two equations together, and when we do that, the 3x and negative 3x cancel out. We add the y terms together, 4y plus 7y is equal to 11y, and then we add the constants together, 21 plus 12 is equal to 33. So we've added the two equations, gotten a whole new equation in just one variable, and now we can easily solve for y by dividing both sides of the new equation by 11. So y is just equal to 3. And we go back, we'll retrieve one of the original equations. I am going to use the first one, and I'll rewrite it down here, 3x plus 4y equals 21. And then we'll substitute 3 for y in this equation in order to solve for x. So 3x plus 4 times 3 is equal to 21. Now we'll simplify, 3x plus 4 times 3 is 12 equals 21. Subtract 12 on both sides, 3x equals 9, and then we'll divide both sides by 3 to get x equals 3. So the solution to this system is x equals 3 and y equals 3. Okay, one example down, let's do a couple more. So we have 6x plus 5y equals 26, and 4x plus 5y equals 14. Now, in the first example, we had a pair of terms that were opposites, namely 3x and negative 3x. We don't have any pairs of terms here that are opposites, but if we look at the y terms, you'll notice that 5y and 5y are identical terms. So what we can do with this system is we can subtract the equations in order to eliminate the y terms, and then we'll solve for x. Just to reiterate, if you have a system of equations where a pair of terms is opposite, we add the equations. If the terms in question are identical, then we subtract the equations. Now, if you wanted to, you could always manipulate a system of equations so that you're either always adding or always subtracting, but I think it's helpful to know how to do it both ways here. So again, we'll subtract the two equations. So 6x minus 4x is going to be equal to 2x. 5y minus 5y, again, since those are identical, we're subtracting a term from itself. Those cancel each other out. And then 26 minus 14 is equal to 12. So now we've created another equation in just one variable. We can solve for x by dividing both sides by 2, and x is equal to 6. Then we take one of the original equations. I'll take the second one this time. So 4x plus 5y equals 14. We'll plug 6 in for x, so 4 times 6 plus 5y equals 14. We will simplify. 4 times 6 is 24, plus 5y equals 14. Subtract both sides by 24, so we have 5y equals negative 10, and then divide both sides by 5, so y is equal to negative 2. Now the solution to this system would be x is equal to 6 and y is equal to 2. Okay, let's do one more example here. We have 8x, we gotta fix that 8, minus 3y equals 31, and 11x plus 6y equals 46. Now this one looks a little bit trickier than the previous two because neither of the pairs of terms, neither the x's or the y's, are identical terms or opposite terms. So what do we do here? Well, if we don't have a pair of identical or opposite terms, what we can do is we can look at the coefficients of either the x's or the y's, and we can find the least common multiple of those coefficients and manipulate the equations accordingly so that the terms are either identical or opposite. So we can pick here. I'm going to go with the y terms. I think it would be easier to find the least common multiple of the coefficients of the y terms. So the coefficients are 3 and 6. The least common multiple would just be 6 because 3 goes into 6. It's a factor. Now, with that said, we don't have to do anything to this second equation because the coefficient is already the least common multiple. So the only equation that we have to manipulate is the first one. Now, how do we get from negative 3y to negative 6y in order to make the two y terms opposite? We just multiply by 2. But we can't do it with just one term. We have to multiply the whole equation by 2 in order to keep the balance, so to speak. So I just multiply this side by 2, multiply this side by 2, and I'll rewrite that down here. If we multiply both sides of the first equation by 2, we have 16x minus 6y equals 62. And then again, the second equation remains the same. I'll just rewrite it down here. 11x plus 6y equals 46. So now we have a system of equations where the y terms are opposites. So we can add the two equations together, solve for x, and then go back and solve for y. Okay, 16x plus 11x, that's going to be equal to 27x. Negative 6y plus 6y, those cancel out. And then 62 plus 46, 108. Then to solve for x, we just divide both sides by 27. X is then equal to 4. So last step, we will go back. We'll take one of the original equations. I'll take the second one again, and I'll rewrite it over here. 11x plus 6y equals 46. And we'll plug 4 in for x. So 11 times 4 plus 6y equals 46. 11 times 4 is 44. Plus 6y equals 46. Subtract both sides by 44. So 6y equals 2. And then just divide both sides by 6. And then y is equal to 2 over 6, which simplified is 1 over 3. So the solution to this system of equations, x equals 4 and y equals 1/3.